So about 2 weeks ago, I showed off my new, to me, Thinkpad T530. I talked about kind of my initial impressions, getting the device, upgrading the RAM, and getting it set up with Arch Linux. I've been really happy with it since then. I've been using it every day, and honestly, when I'm not making videos, I'm not using my MacBook very much anymore. I've been enjoying my Thinkpad a lot, and after making that first video, there were immediately a couple of kind of new directions that I wanted to go with my explorations here, and that's kind of what we're going to be talking about today. I think I'm going to be introducing kind of a two-part problem here. Well, not a two-part problem. This is just going to be kind of a two-parter. The first section is going to be talking about the kind of first part of the project, which was core booting the ThinkPad, and that in itself, I think, will be a decent conversation today. And then we're going to talk about what came after core boot kind of towards the end of the video. And then I think that will have to get its own video sometime next week where I can kind of go into more detail and show that off on its own. Because I mean, yeah, I've definitely been busy here on the T530. And so I'm excited to be talking about it today. And I think I can just kind of get into it now. So to kick things off, I guess the initial conversation about Coreboot on the T530 is just a kind of note on compatibility. This device ended up being kind of like perfect for an initial introduction into this kind of ecosystem. I've never worked with this kind of stuff before. I'm generally very unfamiliar with this sort of project. So my journey kind of started with the Ivybridge exploit. The T530 is a third generation Intel i5, at least from the factory, and that means that it is susceptible to a series of exploits, otherwise known on GitHub as Ivybridge. I'm going to talk about that project just a little bit here. It's a series of scripts and exploits, and that's pretty much all I can say about it. I don't know too much about what goes on under the hood. They have made this whole process really, really easy. The idea here is that you flash this script to a bootable drive, you power off your system, you boot into that drive in UEFI mode, you run the script, and it just does some things for you. Kind of cool. So you get a fully unlocked kind of BIOS menu, and so what that means is you get access to things like fan controls and your RAM settings, so you can overclock and adjust your speeds. You can also kind of soft disable the Intel Management Engine. The menu for that appears. I don't know. I'm not going to say that I'm one of those people who cares a whole lot about this, but it was cool. Might as well turn it off. Outside of that, you can also overclock your CPU and you can put whatever wireless card you want in the device now. It gets rid of the whitelist that exists by default. And so all of these things are cool bonuses. I really didn't see a reason not to do this. They do have a disclaimer on their README. I guess it would be irresponsible of me not to acknowledge that things can go wrong. But my understanding of the way that all this works, so long as the system has power, is plugged in, and some like random act of God does not take your system out in the 30 seconds that it takes to run the toolchain, this is pretty safe. I had no issues with it. It was quick, it was easy, and I have done nothing but benefit from it. So I encourage you to do your research if this is something that you're interested in, but also don't let any kind of irrational fear that some guy on Reddit is trying to instill upon you hold you back from doing this mod. So that's pretty much all there is to the Ivy stuff. It was a cool process, but it's fairly easy. And if you want to know more about it, the link to the GitHub repository will probably be down below in the description. Once I had done this, I was pretty happy for a while. Eventually, curiosity got the best of me though. So during this whole process, they tell you before you do the flash that you can flash a custom image to your BIOS using the Ivybridge toolchain. And they mentioned Coreboot by name. And so I went and I looked up Coreboot and I was like, wow, this is cool. So there's Coreboot, there's LibreBoot, there's, derivatives of both, but the idea is a free and open source BIOS that you can kind of customize to your heart's content. I don't know anything about this stuff. This was probably maybe not the best idea for me to kind of jump into blind like I did, but you are always going to have no idea what you're doing the first time, so I figured, why not? this ended up once again being really worth my time, and I think this was far more educational and kind of interesting to do than the Ivybridge exploit was. And I'm excited to kind of talk about this. The first kind of stage of Coreboot on the ThinkPad came in the form of Skulls. It is a Coreboot distribution that supports a handful of older ThinkPad devices. What's nice about Skulls is it is a pre-built image. It has, support for a smaller list of devices than Coreboot or LibreBoot does on its own. You don't have to go through any of the headache of building anything or getting the pieces from the proprietary blobs by yourself. It just kind of works. So the Skulls process is kind of an intermediary step between the kind of simplicity of what we were able to accomplish with Ivybridge and the kind of full control that you get out of building your own Coreboot. It's kind of a nice middle ground if you have a supported ThinkPad device. The T530, once again, lucky for me, was one of these devices. So the gist of this is it already has a CBIOS image bundled in there, and all of the things that you need for your ThinkPad to just work once you have the Coreboot going. The kind of process for this is a little more intensive than what we did with Ivybridge, but it's nothing too crazy. So Ivybridge kind of opened the door for us here. It allows us to go into our advanced BIOS settings and enable the setting that lets us downgrade the BIOS. This lets us downgrade to version 2.6. This is important because this version has some unpatched memory exploits, and we're going to use those in order to be able to internally flash our 4 megabyte BIOS chip. When I specify the 4 megabyte BIOS chip, we'll talk more about that soon, but it's important to note that on the T530, there is kind of two pieces here. There is an 8 megabyte chip that houses like the Intel Management Engine and the Watchdog kind of stuff, all the other things. The BIOS actually just lives on this little 4 megabyte chip, and that is what makes the internal flash kind of so easy on this device. And so what we have to do, the reason why we downgrade to version 2.6 of the Lenovo BIOS, is that there is another kind of exploit toolchain that we can use with a kind of bundle of Python scripts called chipsec. Basically what we do is we read a bunch of memory values to kind of see what the state of the BIOS is, and we ultimately find we can't write to the BIOS. And so what do? We run this script, and this script tells us to suspend the machine. And when we wake it up, that write protection has been turned off on the BIOS. This is pretty interesting. I would love to say that I understood this more. I read through, all of the docs. Like, I understood what I was doing, but there is definitely someone way, way smarter than me that figured out how to do this. So I am not going to even try and kind of butcher this explanation too much. But once we've done this and we've exposed the BIOS to being able to be written, that is when we can run the Skulls script. It literally just has like an install.sh script in there, and it knows kind of by default what to do. And so this is what's kind of nice about using Skulls rather than going straight into full Coreboot. This little script that it has, the skulls.sh, it like looks at your system, it understands what's going on. If it sees that it can't write to the 8 megabyte chip, it knows that it's only flashing the BIOS, and so that gives you some peace of mind. That's really all there is to it. Once you run the script and you flash the BIOS, it will tell you once it's done. If you do a reboot, you should no longer see your Lenovo splash, but you'll see the Skulls logo, and rather than your kind of typical boot sequence, you'll see CBIOS, and if you're me, you'll also then end up in Grub, and then things will be normal. Immediately, that's like the biggest change that you see, but long term, what you've done is you've kept the system wide open. So this exploit that you had to do to flash the BIOS chip before, you don't have to do that anymore. The reason why that's nice is because now you have a core booted system, and you can go to the Coreboot kind of GitHub repository. You can pull it down, and now you can build your own images. And so once you've built those images, you can just flash them as many times as you want. I don't encourage you to go do a bunch of, random pointless flashes, but the idea is you can kind of start to kind of tailor your system to your wants and needs at this point. And the huge benefit of doing all this with the internal flash is you don't need any of the external hardware. That's kind of a huge bonus to the Ivybridge stuff. There is a clear path to get up to this point without any other hardware. The biggest caveat to that, if you do care deeply about the Intel management engine, you cannot fully disable that going this route. It's off, but it's not removed. You can't remove it. You can't run any of the cleaner scripts. That does require an external flash. And so right now we have a completely unlocked BIOS and we've turned off the Intel engine, but it's not gone. That does require the external flash. Kind of taking all those pieces together and kind of the confidence and knowledge from the experience of doing the skulls and Ivy flashes, the kind of final piece to this all was eventually building my own Coreboot image, kind of based around my own needs. Much like Ivy before it, there was really nothing wrong with skulls. I just eventually, curiosity got the best of me and wanted to kind of dig a little deeper here. With the BIOS now like completely opened and available for me to continue flashing, I started looking into what it looked like to build a Coreboot image, and I was surprised that it wasn't too bad. You can do the whole thing just through like the ncurses menu for the makefile. You're essentially just picking your device and then customizing all the different settings that you either do or do not want. And for me, this came in kind of two waves. The first time I did it, I just wanted a different like boot splash, and that was about it. I ran that one for a day or two and ultimately ended up kind of getting rid of it and going in a totally different direction. I started trying to install FreeBSD on this thing. The FreeBSD installer was having a really terrible time with the kind of default settings that the Coreboot has for this system. It was honestly a total headache trying to get this working. I was really out of my element. I don't know much about all of this stuff, and so it really was iterative trial and error as far as figuring out the correct settings and kind of combination of things to get me where I needed to be. In the end, it was a combination of text-only mode and having to manually extract the like Intel HD drivers from the proprietary Lenovo blob, like from a backup I made of the stock BIOS, and building that into the Coreboot. And those combination of things, FreeBSD was finally happy, and I was able to get the installer going. The installer was great. I went with FreeBSD 15. I have never used a BSD before outside of like a singular virtual machine sometime last year. And that was, I dare say that, that was really usage. That was a couple hours of messing around. That's been super cool. I'm dual booting that alongside of Arch now, and they've been playing very nicely with each other. I've been kind of trying to daily drive FreeBSD as much as possible. I ran into a pretty gnarly wireless issue while I was in class today, and that was honestly not even FreeBSD's fault, but it really looked like it was for a while. So we'll talk more about that at a later time. This one's already kind of running on pretty long. So circling back to my original point here, I think this is going to be the kind of break off and pivot point where I will say that next week we're going to talk more about what I've been up to on FreeBSD. Definitely excited to share my thoughts on using it and kind of just, it's been really cool coming from a kind of newer Linux background. The docs are great and the community is very helpful, so I've enjoyed the process so far. And once I got the machine to a kind of usable state that I was happy with, it's been honestly like really pleasant. So definitely excited for that next week. Keep your eyes on the channel for that if that's something that you are interested in or looking forward to. I think that's going to be just about it from me today. I've been talking for a little while here. Thanks for kind of stopping by once again, taking some time out of your day to listen to me talk about my ThinkPad once again. This one was, a very cool process for me, and I was definitely excited to kind of compile all of this into one place because it was quite the journey trying to figure this all out on my own. the docs for all these projects are great, but without the kind of prior exposure to a lot of these fields, it felt like a lot. And so I'm hoping that, maybe someone in the future will find this video and think that it's even a little bit useful. So with all that out of the way, that's just about it from me, and I will see you guys next week.